In this part of the activity, we're going to look at some group 2 metals, or alkaline earth metals. You had previously seen sodium and potassium and how reactive they were. Those are group 1, or alkali metals, the most active group of metals. Now you're going to watch the next best. So, since they're not quite as active, we couldn't use water to show how reactive these are. We have to use hydrochloric acid. But you'll still get a pretty cool reaction. If you look at magnesium before I add it to the hydrochloric acid, you can see that it's a silvery metal, a little bit shiny. It's malleable, can be rolled into thin sheets, just like all metals. And then I'm going to add it to the hydrochloric acid, and you're going to watch a reaction. You'll see that it reacts relatively violently, and you can see the rapid bubbling. This would not happen if we placed it in water. So the reason I put a watch glass over this, or the evaporating dish, is so that I can trap the hydrogen gas that's being generated. Then I'm going to show you what happens when we ignite that. Now, in the previous reaction with potassium, that released so much energy that the hydrogen gas ignited spontaneously. In this case, I'm going to have to add a little fuel to the fire. And we get a nice cool sound. Alright. Now I'm going to show you what happens when I react some calcium metal. Now, the only reason I'm using a different container here is that you can get a little bit of a different sound with a different shaped container. So, we'll see what happens when we react our calcium. This is a piece of pure calcium. It doesn't look like you've probably seen it. Because calcium's lower on the periodic table, it's slightly more reactive than magnesium, and it gets corroded rather rapidly. In fact, we've already tried this once before with a more corroded version of this, or a more oxidized version, which actually looks more whitish. Alright, so metallic looking, grayish. We're going to add it to the hydrochloric acid. You can see that this reacts violently as well, even a little bit more violently than the magnesium. And we're going to just let this fill up with hydrogen gas for a moment as it's reacting, and then I will ignite it. Okay, see how this goes. Pretty cool, huh? Alright, so let's go over to our chart. Maybe we'll get to do that again. We'll describe these two things. So these were both, this was a little bit more, magnesium was a little bit more silver in appearance, a little bit shinier, where calcium wasn't quite as shiny. It was a little bit more dull, but it still had a metallic, dull gray color. Right. Now, both reacted violently. And produced hydrogen gas. And same with calcium, so that reacted violently as well. And produced hydrogen gas. Okay. Now, the flame didn't react with the magnesium or the calcium, but it reacted with the gas that we created, the hydrogen gas. The product action with flame ignited, and this ignited as well. Because hydrogen gas is a combustible material, very flammable and somewhat explosive, as you saw, it makes for a pretty fun reaction. These are both group 2. And they are known as alkaline earth metals. Alright, so both very reactive. Now, we're going to write out the chemical equation for this reaction. Similarly to potassium and sodium, when they react with another substance, they can produce a basic solution. That's why they're called alkaline or basic earth metals. So if I react magnesium with hydrochloric acid, I generate two things. I generate magnesium chloride Chloride having a -1 charge as an ion, magnesium +2 because of its column that it's in. Therefore, they combine in this ratio. In addition, it made the hydrogen gas, which we subsequently ignited. Now, this again is an unbalanced equation. So I would have to have 2 HCl's to make this happen. So I want you to predict the other reactions that you see below. In addition, I want you to predict, what do you think strontium would be like? Do you think it would violently react as well? That's for you to decide.